Hello, my name is Joe Davies, Industrial Computing Product Specialist here at Amplicon. In this video, I will guide you through all the aspects that you should be considering when specifying an industrial computer. Let's get started. Key points that I'll be covering include a brief overview of an industrial computer, software and hardware considerations when choosing an IPC, and the specific hardware requirements based on the environmental conditions. Industrial computers are robust systems designed to meet demanding environmental requirements, delivering maximum reliability and high performance. An industrial computer typically has the following characteristics. They are rugged. Thanks to their superior design, industrial PCs withstand harsh environments, extreme temperatures, dust, vibration, and moisture. They offer long-term availability. You'll find that most industrial PCs come with a 10 to 15 year roadmap, depending on the CPU manufacturer. And also, they deliver high reliability. Industrial PCs can run 24/7 and offer excellent uptime performance. Here at Amplicon, our computers have an unbeatable 0.02 failure rate. For all these reasons, commercial grade computers are not suitable for industrial projects or applications. Industrial computers come in different forms. The most popular are Rackmount Computers. They are designed to be mounted in a 19-inch rack cabinet and have the capability to have large quantities of expansion cards as well as multiple hard drives or solid-state drives. In addition, due to their wide temperature nature, they don't necessarily need to be housed in a server room. Rack-mount systems typically come in two flavors, motherboard-based or single-board computer and backplane based. In a motherboard-based system, the slots, processor, RAM, etc. are all fitted on the same board. These systems are typically slightly cheaper, but are limited in how many cards you can plug in. For an SBC-based system, processor, RAM, etc. are on one board, which is plugged into the backplane that contains the available expansion slots. SBC-based systems typically have far more slots, which means they are more expensive. Other popular forms include tower PCs, embedded PCs, and panel PCs. Tower computers give you the option to have a good number of expansion cards, as well as multiple hard drives and SSDs. Embedded computers are typically fanless, might have the capability to install 2 to 3 cards, and are typically small form factor, capable of being mounted by DIN rail or wall mount. Panel PCs are an all-in-one computer and touchscreen. Designed to be mounted on the front of a panel, these often have aluminium bezels to protect them and allow an operator local access to control equipment without the need for a desk. So, what do we need to consider when specifying an industrial computer? The starting point is to look at what your computer is going to be doing, and therefore what software you will require for the project. Depending on your application, you will have acquired a specific software that offers the programming features that you need. And it is precisely the characteristics of this software that will take you down one hardware route or another. Of course, one more factor needs to be taken into account at this initial point, and that is the environmental conditions of the location, where your computer needs to be installed. This will also have a major effect on the hardware you choose. I will start by explaining all the considerations you need to make based on your software, but always keeping in mind that all decisions along this route will need to match the physical location conditions. Depending on the operating system you have chosen for your application, you will realize that you may be limited to specific components such as the processor. For example, Windows 7 only operates on a 6th generation Skylake-based system or earlier. Also, we need to look at how intensive the software you are using is. Is it a lightweight program that runs on an ARM or Atom processor? Or are you looking at a massive processor hog that requires 10 cores and 64 gig of RAM? It is crucial that you are aware of the minimum or recommended hardware needed for the optimum performance of the software you are using. Once you've answered all of these questions, you will know if you require a low power or high power system. At this point, we can start looking at the CPU requirement. How many cores you need, what generation of CPU do you need, And does your application make use of hyperthreading? Hyperthreading is a technology in some processors that allows the processor to work on two sets of data, threads, at once. This doesn't necessarily mean the processor is twice as quick, but would definitely be faster. However, your application software would need to be written around this capability to take advantage of the speed gain. Based on these decisions, you might be looking at an I-core-based system or a lower power Atom Celeron-based system. Another piece of hardware you need to consider is the RAM. How much RAM do you require? I would always recommend at least 4 GB of RAM for Windows 10 based system, but this really depends on your application. If your application requires high quantities of RAM, looking at a small fanless PC likely won't meet the requirement. Storage is the next major decision point. Do you want a solid state or mechanical hard drive, and how many? Solid state drives and hard drives each have their own benefits and drawbacks. SSDs are faster and more durable, but suffer a short life in conditions where a large amount of data is written to the SSD and then erased. This is known as a write erase cycle. SSDs are built from groups of NAND cells, and every time you go through a write erase cycle, you damage the NAND cells, which eventually leads to the cells dying. Over time, this causes the SSD to have reduced storage capacity. Hard drives aren't affected by a write erase cycle and have large storage sizes, but they suffer in extremes of heat, cold, vibration, and shock. Depending on your requirements, you may want to go down one route or the other, or a combination of both. With storage, it isn't about capacity and speed, it's also about size. SSDs and hard drives typically come in 3 types: M.2, 2.5 inch, and 3.5 inch. There are other types and sizes, but these 3 are the most common. The size of the system and the amount of SATA ports or M.2 slots will limit how many drives and of what type. If you require terabyte upon terabyte of storage, you need to look at a rack mount solution, not embedded. My recommendation for most systems is to put the operating system and any software on an SSD and have a hard drive for storage. This allows you to leverage the speed of an SSD, but have the mass storage capabilities and low cost of a hard drive. Another consideration is RAID. Do you require it? RAID, which stands for a redundant array of independent disks, is a technology that allows you to build redundancy into your system. RAID allows you to create an array of disks where all the data is stored across multiple disks, not just one. So, if a drive fails, you won't lose any of your data. Do you want all drives in one array or have multiple arrays? Using a RAID array gives you an option to make your system more redundant, but beware, the extra drives will increase the cost. How critical is the application? Do you require all drives in the RAID array, or just the OS, or just the storage? Working through our system requirements, we now need to look at expansion. Expansion slots allow you to add expansion cards, be it a graphics card, serial card, or data acquisition card. The card you want to add will have a big effect on the system you need. Size, are they full height or full length? This will determine the size of the chassis you need to use. PCI, PCIe, how many PCI or PCIe cards do you require? The amount of cards will also affect the system you are looking at. Is it a high power expansion card or graphics card that requires supplemental power? Also, how many cards do you want to add? The majority of I-core based systems are limited to 20 PCIe lanes. If you want to add cards that require more than 20 lanes, you need to look at a Xeon based system. What are you planning to plug into the computer determines your I/O requirements. How many ports and what types? If you're plugging in a high performance USB camera, you might want to consider USB 3.2 Gen 2. If you need serial, what protocol do you need? What speed of Ethernet port? What protocols? Display is another consideration. With most systems, you can use the onboard display connectors, usually a combination of VGA, DVI, DisplayPort, or HDMI, for potentially up to 3 separate screens, depending on the board. However, you might want to add a graphics card for more graphics-intensive requirements or for applications that require additional screens. When thinking about how you are going to display your data, you may want to consider if the unit would be better off as an all-in-one PC and screen. This gives you the option to mount the PC in a panel, protecting the sensitive PC parts, while giving an operator a local screen and PC to control the equipment. Now we have looked at the hardware system requirements. We can work out how much power the hardware is going to draw. This can help you choose the power supply you need. Best practice is to select a power supply where the maximum power draw of the system does not exceed 80% of the maximum rated power of the power supply. Ideally, you should add a little extra buffer for any future upgrades. With the wattage of the power supply worked out, you can now decide the input. Do you require mains 240 volt AC or DC? Another consideration for power supplies is redundancy. Having a redundant power supply gives you 2 or more power inputs into a PC, which, if one of the power modules fails, the system will continue running. This is often essential for systems storing data or housing critical software. Now we've worked out the majority of the hardware, we can start to piece together a specification. Depending on the choices you have made, you will choose one of the 4 computer categories for the type of system you need. For example, if you require large quantities of plug-in cards, you'll be looking at a rack mount system. If you only require a small amount of processing to be mounted inside a machine, you'll be looking at an embedded system. As I mentioned earlier in this presentation, the physical location of the PC plays a crucial role in the final decisions. Once you've determined the hardware required to meet the software specs, you need to make sure it perfectly matches the environmental conditions of the location where you plan to install the industrial PC. Is it going to be an office or server room? Is it going to be fitted in a cabinet in your factory floor? Or maybe it's going to be fitted in a roadside cabinet outdoors. As an example, if your PC requires to be installed in a dusty, damp or corrosive area, a fan computer would not be suitable as it will fail. For these types of environments, the use of a fanless industrial PC is a must. Having a fan system allows you to operate in a hotter environment, use a higher wattage CPU, or have high power expansion or graphics cards. But this isn't suitable for a dusty environment, as the dust will eventually blanket the components, causing it to overheat or short, depending on what is in the dust. On the other hand, a fanless solution allows you to install the PC pretty much anywhere, but now you are limited by the convection properties of the heatsink, which will force you to go down to a low wattage CPU and a low wattage expansion card. So, over the course of this video, we have discussed what an industrial computer is and the decision points you may reach when specifying an industrial PC. I hope this guide has given you the information you need to be able to specify an industrial computer for your future projects. In the coming months, we'll be releasing more informative videos featuring in-depth video tutorials on the various aspects of industrial computers, such as storage hardware, RAID, power supplies, and processors.